The device you're watching this on can do trillions of things per second, but it can't decide to do anything on its own. It's the dumbest, brilliant machine ever invented. By the end of this video, you'll know why every program, Minecraft, ChatGPT, your banking app, reduces to just 6 operations. A computer is a machine that mechanically executes algorithms, nothing more. It excels at 2 things, storing data and performing simple operations very fast. It has 0 autonomy. Think of it as an obedient worker who follows instructions literally, with no judgment, no creativity, no initiative. The only superpower is speed. A trillion trivial steps per second. Brilliance emerges from quantity, not intelligence. Before the 1940s, computers were fixed program machines. Take a pocket calculator. Each button is a single operation hardwired into the circuitry. Press plus, it adds. Press the square root, it takes a square root. You cannot save a sequence of presses. You cannot teach it a new trick. One device, one fixed set of operations, one purpose. If you wanted a different computation, you literally rewire the hardware. This is why early computers filled rooms and solved exactly one problem. The 1940s brought the breakthrough, the stored program computer. Instructions themselves became data stored in memory alongside the numbers they operate on. A special program called an interpreter reads those instructions one by one and executes them. The same physical machine can now run a spreadsheet, a game, or a chatbot, just by loading different instructions. This is the invention that made software possible. Hardware stopped being the program. Hardware became the stage on which any program could perform. Inside every stored program computer, 3 components do all the work. Memory, a giant grid of numbered storage cells, each holding a value. The ALU, or Arithmetic Logic Unit, a circuit that performs one operation at a time, like adding 2 numbers or comparing them, and the control unit, which tracks which instruction comes next using a pointer called the program counter. Control unit fetches an instruction, memory hands operands to the ALU computes, the result returns to memory. Watch one actually run. Memory address 3456 holds the value 3, address 3457 holds 4, address 7891 holds 7. The first instruction adds the values as 32456 and 3457. The ALU fetches 3 and 4, returns 7. Next instruction, store that 7 at address 3458. Now another add and store fills more cells the same way. Next instruction, compare the value at 3458 with the value at 7891. Both are 7. The ALU returns true. Final instruction, print the result. The screen outputs true. Notice how excruciating that was. 5 instructions to add 2 numbers and check a value. Real programs run billions of these per second. Writing them by hand, one address at a time, is humanly impossible. That's why we invented higher-level languages, Python, Java, C++. You write one readable line, and the translator turns it into the thousands of tiny memory and ALU operations. The machine actually performs. The computer never gets smarter. We just stop speaking to it in its native baby talk. Now the deepest question. How few operations do we actually need? In 1936, Alan Turing answered it. He imagined a machine with an infinite paper tape divided into cells and a single read-write head hovering over one cell. Turing proved that any computation, anything computable at all, can be performed with just 6 primitive operations on that tape. Move the head left, move the head right, read the symbol in the current cell, write a symbol, erase a symbol, or do nothing, a no-op. 6 actions. That's the entire toolkit. The implication is shocking. If every computation reduces to those 6 primitives, then every programming language ever invented is just a different way of arranging the same 6 actions. Python, Java, Rust, JavaScript, C, even languages not yet written, all compile down to the same primitive operations. Anything computable in one language is computable in any other. They differ in convenience, readability, and speed, never in raw capability. This property has a name. A language that can express all computations is called Turing complete. Almost every language you've heard of qualifies. Step back and consider what you now know. A computer is a machine with no judgment, no awareness, no intelligence. It stores numbers in cells, runs them through a small set of operations, and tracks which instruction comes next. The leap from fixed program to stored program turned hardware into a universal stage. Turing's 6 primitives proved that stage has no ceiling on what it can compute. So when you write code, you're not commanding a thinking machine. You're composing trillions of trivial steps, move, read, write, compare, into something miraculous. The computer stays brilliantly stupid. The miracle is yours.